So welcome everyone. This is our heat lecture 7, right?
Yes, sir.
Do you recollect what we have done till now in heat?
No, sir. We didn't get.
Yes, Peter?
नया है सर अभी तक.
You are new in the class?
नहीं sir.
So I asked you what we were discussing, what we have discussed up till now. What we have discussed up till now? What topic?
Bimetallic strip.
What?
Bimetallic strip, sir.
Yeah, bimetallic strip. So basically we were dealing with expansion of solids, right?
Yes, sir.
We were under the first heading and we were dealing with expansion of solids. Here we have done linear expansion, areal expansion, as well as volume expansion.
Yes.
We have seen what are the applications of thermal expansion, thermal stress, metallic strip, and we have covered almost everything. We have solved some problems as well, and I think that covers your entire spectrum. Now, moving on from expansion of solids, that was the first heading, to the next heading, and the next heading would be expansion of
Liquids.
liquids. Now it is very easy to understand that for liquids you will not have length expansion. Don't say liquid expands in length or liquids expand in area. We have only therefore one type of expansion, and that will be equal to, that would be what? That would be what? Volume expansion, yes or no?
Yes, sir.
Volume expansion of liquids. So what do you mean by volume expansion of liquids? Whenever you are having any liquid and you increase the temperature, its volume increases. If you decrease the temperature, its volume decreases. If I have delta V, that is the change in the volume of the liquid, what will that be equal to?
1 plus gamma delta T.
That will be equal to gamma L, where gamma L stands for the coefficient of expansion of the liquid multiplied by V naught. Let me call it as V naught, which is the initial volume of the liquid, into delta theta. If I call the final volume as V, the final volume will be V naught plus delta V. So I can simply write it as what? This V will, this V will be equal to V naught into 1 plus gamma L delta theta. We all understand this?
Yes, sir.
This gamma L, this gamma of liquid, is very, very large compared to gamma of solid. We also understand this?
Yes, sir.
Because liquid expand a lot more than compared to their solid counterparts. Now, liquids expanding in volume. When volume increases, something else decreases. What is that something that decreases? We have already seen that. We have already seen that effect. When volume increases, what happens to the other quantity? What is the other quantity that we are discussing now? What is the other quantity that we are discussing now? That we are going to discuss. When volume changes, what happens to the other quantity? What is the other quantity? And the other quantity is definitely density. We have seen this. What is the effect of density on temperature? No, what is the effect of temperature on density? When you increase temperature, density decreases. When you decrease temperature, density increases. Yes or no? Now, this decrease or this change in density, whether you talk about liquid, whether you talk about solids, it will be same. So the final density would be equal to, if I call the final density as D, the final density will be equal to D naught into 1 plus gamma L delta theta. Yes or no? This is the exact formula for density. You can also write this formula in this fashion where you have used binomial expansion. Yes or no?
Yes, sir.
We have seen that. Okay, so let us move ahead. You already know this, so let's not waste time. You must be aware of this anomalous expansion of water. Yes or no? You must know this, that water has from 0 to 4 degrees Celsius. When you are going to heat up water from 0, that is the freezing point of water, to 4 degrees Celsius, gamma, the coefficient of expansion is negative. That means that instead of density decreasing, density increases. Yes or no? So water has highest density at 4 degrees Celsius. Do we understand this? Do we know this? And this graph? There have been questions in the previous years on JEE that has come on the anomalous expansion of water. I'm sure that you have idea about this. Yes or no? Pakka? Okay. It is because of this anomalous expansion of water that lake freezes from top to bottom and not from bottom to top. I hope you know this. Yes or no? We will be doing a question where we will find out how much ice, what is the thickness of this ice on the surface of the lake, but that can only be done when we do conduction. So when this conduction wala topic comes, we will come back and see what will be the thickness of this ice. Do you know that lake freezes from top to bottom because of this? Yes or no? We know this, right? Not sorry, I'm not able to hear you. We know this, right or not?
Yes, sir.
Okay. Now, since we have done the variation of density, it's prudent that we solve a problem on this. So this is problem number 22. The problem is very simple. The density of wood and benzene at 0 degrees Celsius are given. So you only get one chance to read the question. 880 and 900 kg per meter cube respectively, the coefficient of volume expansion are this and this. As you can see, wood has a very low volume expansion compared to benzene. At what temperature will a piece of wood just sink in benzene? I hope you know when does a body float and when does a body sink. Yes or no?
Yes, sir.
The question is right in front of you. I'll give you a minute to think about the answer. I'll be back in a minute. Okay, do you have an idea about the buoyant force? Yes or no?
Sir?
You have an idea about buoyant force? Yes or no?
No, sir.
Oh, you have not heard about buoyant force, bacha? Okay.
Boiling force.
Okay. Then I must step in. Big time. Okay. When does a body float? Let me put the question in a different way. When does body float? Any idea? When does a body float?
Density of the body is less. Density of the body is less than water.
So basically you are trying to give me an explanation of when does a body float in water, because body can float in any liquid. A solid body can float in any other liquid. A liquid can float on another liquid. So you give me example of any body floating in water. And you're telling me that it happens when the density of the body is less than that of water. Ships, have you heard about ships? Ships are made up of iron. They still float. The density of iron is less than density of water. Is that so? Or is it more? Okay. Have you heard about the term buoyant force? You have not heard about the term buoyant force. If you've not heard about the term buoyant force, then you won't be able to understand why does body float. Buoyant force. Anyone can tell me what is buoyant force? Anyone can tell me what is buoyant force?
Force applied by the liquid on the body. Upthrust.
Okay, buoyant force is also known as upthrust. Okay, we all understand this. This is a liquid. The black one is a liquid, as you all can see. The blue one is the solid body. The solid body has a density rho s. Do we understand this? And the total volume is Vs. Do we understand this?
Yes, sir.
The density of the liquid is rho L. We understand this?
Yes, sir.
Now, as you can see, some portion of this solid is inside the liquid. Do we understand this? There is some portion of this solid which is inside the liquid. This portion of solid which is inside the liquid, I will call it as VL. Now, what is this VL? This VL is equal to volume of the liquid displaced by the solid. Do we understand what I'm writing here? All this is equal to the volume of the solid which is inside liquid. Do we understand the meaning here? Do you understand the meaning here, bacha?
Yes,
No?
sir. Understood, sir.
You understand this?
Yes, sir.
Okay. Let us take, for example, this is a glass of water and it is completely filled with water. Now, if I put in anything inside it, it is completely filled with water. If I put this pen inside it, will some amount of water overflow? Yes or no?
Yes, sir.
Why?
Volume.
Why will some amount of water overflow? Why it should overflow? Tell me. Why will some amount of water overflow? This jar was completely filled with water, but I was trying to put in something else, maybe a stone or something else. We will find out that some volume of liquid will flow out. Why will some volume of liquid flow out?
The volume of solid immersed
The volume of solid?
will be.
Yes. This vessel has a fixed volume. It cannot increase its volume. Now, this volume is completely filled with water. There is no space inside it. But when I put a solid body, it has to occupy space. It has to occupy volume. To make volume for itself, an equal amount of volume of liquid will flow out. That is known as the volume of the liquid displaced by the solid. Do we understand it now?
Yes, sir.
This is the volume what the solid has gone inside the liquid. That much volume of liquid has to get displaced. Do we understand this now?
Yes, sir.
Okay. Now, what is buoyant force? Whenever a liquid is immersed inside, whenever a solid body is immersed inside a liquid, the liquid will exert an upward force on the solid. The liquid will exert an upward force on the solid. This upward force is known as buoyant force, or you can call it by another name. This is known as upthrust. Yes or no? This can also be called as upthrust. Why does this upthrust come? Can you tell me that? Why does this upthrust come? Why there is not a down thrust? Why there is a upthrust? What is the reason behind for this upthrust? Anyone?
Liquid is applying force.
Why is it applying force? That is the reason. I have already told you it is applying force. I'm asking the reason. Why is there this upthrust? Then this question can easily come in a JEE Mains or JEE Advanced if you don't understand the logic. Why is there upthrust? Why does liquid force or liquid apply a force upwards? Why it does not apply a force downwards? Or why it does not apply any force? Why is this force coming? Any idea?
Through density.
Because of?
Density pressure.
Because of density present. No, that does not sound logical. It's because of difference in temperature. It's because of difference in pressure. This upthrust comes because of difference in pressure. Does it give you some idea now?
Yes, sir.
What now? Can you tell me why this upthrust is coming? Difference in pressure. What do you mean by difference in pressure? You have to understand everything to give an answer, because you can give an answer without understanding anything, and then when a question comes in JEE, you will be caught. This is a liquid, right? This is a liquid, and I take 2 points in the liquid, point A and point B. Which point will have higher pressure?
B.
B, because we know, and we can prove it, and I'm not going to go into the proof. We know that as you go inside a liquid, the more deeper you go, the pressure increases. Yes or no?
Yes, sir.
Now, if I imagine that instead of a point A, B, I have a body. Let us say I have a cylinder here. I have a cylinder here. This is a cylinder. Now, if this is a cylinder now, at which point the pressure is more? Point B or point A?
Point B.
Point B, the pressure is more. Now, I'm going to draw that pressure. So, point B, pressure is more. And now, you must know that liquid pressure acts from all directions perpendicular. Do you know this?
Yes, sir.
Okay, so it will, because of this liquid pressure PB, it will be exerting a force in the upward direction. Yes or no?
Yes, sir.
But at the same time, because of pressure PA, it will be exerting force in the downward direction. Yes or no?
Yes, sir.
Which force is going to more? Let us assume that both the areas are same. I'm not going to get it very complicated. Let us assume that both the areas are same. Which force is going to be more?
PB.
PB wala force, pressure at point B wala force will be more, and that is the simple reason why this solid body will exert, or this solid body will experience a force in the upward direction. Am I clear?
Yes, sir.
Let us keep it at that. This is because of difference in pressure. So because of difference in pressure, the liquid will exert an upward force. That force is known as buoyant force. Do we understand this?
Yes, sir.
Now comes the Archimedes principle. Do you know what is Archimedes principle?
Yes, sir.
What is Archimedes principle?
Volume displaced is equals to density of liquid into mass into gravity.
No, that is not Archimedes principle. Archimedes principle simply states that, if I tell you it in great detail, whenever a solid body is immersed inside a liquid, whether it is partly immersed, whether it is completely immersed, the liquid will exert an upward force. That force is known as buoyant force. That is the definition of buoyant force. Archimedes principle gives us how much is that buoyant force equal to. How much is that buoyant force equal to? That is given by Archimedes principle. Now, can you tell me what is Archimedes principle?
Buoyant force equal to volume displacement.
Buoyant force is equal to?
Volume displaced into gravity.
No, you are definitely very confused. You are not even thinking about the dimensions of force. Volume multiplied by gravity will never give you the dimension of force, bacha. You have to find out the dimension of force first. Okay, so what Archimedes principle states that this buoyant force is equal to the weight of the liquid. Weight and force have the same dimension. Weight of the liquid displaced by the solid. Please note it down. You don't know all these terms. Please note it down, because this is the last time that you're going to hear this before your exams. Please note it down. Weight of the liquid displaced by the solid. Am I clear now? The buoyant force FB exerted by the liquid on the solid is weight of the liquid displaced by the solid. Am I clear?
Yes, sir.
Okay, so this is how you say it, and this is the only way that you say it. Whatever you were saying was absolutely not correct. Weight of the liquid displaced by the solid, never forget it. Now, how do I find this weight of the liquid which is displaced by the solid? Now we get into the formula for that. This was the definition. How do I get this weight of the liquid displaced by the solid? Tell me now, fatafat.
Volume into density.
Yes, now you are coming, sir. Volume into density is still not weight. Beta,
Into
it is
gravity.
mass multiplied by G will give you weight. So be very correct. So this will be equal to volume of the liquid displaced, VL. Do you understand this VL? Multiplied by rho L, which is the density of the liquid, multiplied by G. This will be equal to your buoyant force. Am I very clear about this?
Yes, sir.
I hope no one has any doubt regarding this. Please note it down. This is the buoyant force. This is the buoyant force exerted by the liquid on the solid body, and it is in the upward direction. I'll give you a minute to note it down. Fatafa, note it down. Till then, I will do something else so that I don't waste that time. We are short on time. We cannot waste any time.
Sir, written, sir.
Write it in good language. You are not going to hear it again. This is the last time that you are going to hear it. Till that time, I am going to make something. Give me the time to make it for you. Okay. I hope you have written this.
Yes, sir.
Let us move ahead. And I have now drawn 3 cases here. Can you see the 3 cases?
Yes, sir.
Okay. Case number 1, as you can see, body is floating. Case number 2, the body is still floating. In case number 3, what I have shown is body is sinking. Yes or no?
Yes, sir.
Okay. What is the difference between case number 1 and case number 2? What is the difference between case number 1 and case number 2? Do you understand the difference?
Buoyant force is not equal to mass of the solid. In
What?
case, buoyant force is not equal.
Please speak up loudly, beta. I am not able to hear you. Why are you speaking so slowly?
In second case, buoyant force is equals to weight of the solid.
In first case, it is not equal.
Equals to the volume immersed into density of liquid into gravity.
Okay. Let me draw the free body diagram in all the cases. There must be a weight of this body, mg. Now, if there is nothing to stop it, it will go down. Yes or no? Yes or no?
Yes, sir.
Something is stopping it. That has to be the buoyant force. So here, FB should be equal to mg. Yes or no?
Yes, sir.
Let me draw the free body diagram here. mg, something must stop it. What is that stopping thing? FB. FB is equal to mg. So remember, what is the condition of floating? What is the condition of floating?
FB equal to mg.
Yes, the condition of floating has to be FB equates mg. This is the condition of floating. Nobody in this universe can change this condition. This is the condition of floating. Do we understand this?
Yes, sir.
Nobody can change this. So whatever answer you gave me, it is valid for both the cases. In both the cases, buoyant force has to be equal to weight, else it does not float, my dear friends. But there is a subtle difference here. What is the subtle difference? If I look at case number 1, in case number 1, it is floating, but some part of the body is outside the body, is outside the liquid. Do you see this?
Yes, sir.
In second case, it is still floating, but the entire body is inside the liquid. Do we understand this?
Yes, sir.
The second case is known as the case of just floating or about to sink. Even if I put a drop of liquid on the top, this body will sink. So this is the case of just floating. This is the case of just floating. Do we understand this? Somehow it is floating and it is just floating. Do we understand this?
Yes, sir.
Just floating or it is just about to sink. If I even put a drop of ice, if I put a drop of sand onto it, it will just sink. In case number one, though the case is different, it is floating. Some volume of this body is outside the body. Yes or no?
Yes, sir.
Now let me write the blue things. The blue things is Vs and rho s. Do we understand this Vs and rho s?
Yes, sir. Volume.
Vs is the total volume of the solid. Rho s is the volume, is the density of the solid. We understand this.
Yes, sir.
Then I have rho L and VL. Do you understand rho L and VL? Do you understand rho L and VL?
Yes, sir.
What is rho L?
Density of liquid.
Density of the liquid. What is VL?
Volume displaced by the solid.
Volume displaced by the solid. Now I use this equation that FB must be equal to mg. What is FB here? What is FB here?
Buoyant force.
Buoyant force is VL
Royal.
into rho L into G. Yes or no?
Yes, sir.
What is the weight? VS into
rho
rho S into G. We understand this? Yes or no?
S. Yes, sir.
G, G and G goes to heaven. So I have this very beautiful condition coming to me, and that condition for floating for this particular case is VL into rho L is equal to VS into rho S. Do we understand this?
Yes, sir.
Well done. We understand this. Now we can draw a very good inference from here. I hope everyone is noting it down. This is the last time that you're going to see it. Please note it down. Now, there's a very good inference that I can draw from here. What is the inference that I can draw from here? Can you see that inference? What is the inference I can draw from here? Here, VL is less than VS. Yes or no?
Yes,
The
sir.
entire volume is not inside. Some volume of the solid is outside. We understand this? Yes or no?
Yes, sir.
What does this imply? This imply that rho L would be greater than rho S. This is how you understand why does a body float. If the density of the liquid is greater than the density of the solid, the body has to float. It will float in such a way that some volume of the solid will be outside the surface of the liquid. Am I clear?
Yes, sir.
Please note it down. This was my case number 1. This was my case number 1. Case number 1. Have you noted down case number 1?
Yes, sir.
Case number 1. Solid floating on liquid. Some volume outside the liquid. Case number 1.
Completed.
Copy it. Now let us move on to case number 2. Case number 2, the condition is still same. Buoyant force has to be equal to the weight. Now let us find out how much is the buoyant force in this case. How much is the buoyant force in this case?
VS Royal G.
Yes, the entire volume is inside. So Vs rho L G. And this is again Vs rho S G. Nothing changes here. Yes or no? Now two things goes to heaven. This one and this one, this one and this one. Yes or no?
Yes, sir.
So the condition I have now is rho L is equal to rho S. So as long as the density of the two liquids are same. Oops, why this has become ulta? This should come see. Okay. As long as the densities of the two bodies are same, if the density of liquid is more, it will float. Some volume is outside. If the densities become equal, it will float, but entire volume will go inside. This is my case number 2. Do we understand this? This is my case number 2. It floats, entire volume is inside. Now let us move on to case number 3. What will happen in case number 3? What will happen in case number 3? Tell me. In case number 3, it has already sunk. It has already sunk. Now let me draw the free body diagram. This is the weight mg. And this is the buoyant force FB. Yes or no?
Yes,
And now, since it is sinking, this weight mg is greater than the entire buoyant force FB. Do we understand this?
yes, sir.
So it will have a net force in the downward direction. Do we understand this? It will have a net force in the downward direction. Do we understand this?
Yes, sir.
That net force in the downward direction can be called as apparent weight. Do we understand this? Bodies which are inside the body, which are inside liquid, they feel lighter. Have you seen this? They feel lighter.
Yes, sir.
Why they feel lighter? Because liquid is pushing them up. But this liquid push, this liquid buoyant force, this upthrust, it is not equal to the weight, and that is why this body cannot float. This body has to sink. But the buoyant force is still there, and you will see the effect in terms of its weight will appear to be less, or it will appear lighter. That lighter weight is known as the apparent weight of the body. Do we understand this?
Yes, sir.
So this apparent weight, so I write it weight apparent. Do we understand weight apparent? This will be equal to weight real minus FB. Do we understand this?
Yes, sir.
Now, sometimes this apparent weight is also known as weight in the liquid. Do you understand this? Weight inside the liquid.
Yes, sir.
This will be equal to weight in air minus buoyant force. Do we understand this?
Yes, sir.
Different ways I am writing the same thing. I hope everyone is noting this down. So now I can write this weight inside the liquid is weight in air. How much is the weight in air? Vs rho s g. How much is the buoyant force? Vs, entire volume is inside. Vs rho l into g. Everyone is following me? Yes or no? So this apparent weight or weight inside the liquid becomes Vs and g jump out. It is rho s minus rho l, and this is how things happen in case number 3, which is the case when the body cannot float. Why the body cannot float? Because whatever buoyant force is capable of doing, it is not able to balance the weight, and there is a net force in the downward direction. That net force can be called as the apparent weight, and that is how we can find out the apparent weight in case number 3. Is it clear to everyone?
Yes, sir.
So this was the entire theory on weight and upthrust and buoyant force and sinking and floating of a liquid, floating of a solid body inside liquid. Can I move further? Let us bring our attention back. Back where? Back where? Where were we?
Expand.
Let us bring our attention back to the question in point. And what is the question in point? And the question in point is this. I again give you a minute to solve it. Yes, so we have done this.
Yes, sir.
Does it have, whatever I have told you, has it made any difference in your solving the question? Yes or no? Okay, so what I need to find out is that the body just sinks. Now, when it just sinks or just floats, what is the condition of just sinking or just floating?
Rho 1 equal to rho 2.
Their densities has to become equal. If their densities become equal, even a very slight change will cause it to sink. So density of the liquid has to become equal to the density of solid. This is the density of the solid. If I raise the temperature by theta or delta theta, yes or no? So 880, which is the original density, divided by 1 plus gamma s into delta theta, that will be equal to 900 divided by 1 plus gamma L into delta theta. So from here, you can find out the value of this delta theta. Am I clear?
Yes, sir.
Okay. I'll give you a minute to note this down. So the next thing, we have already seen that the liquid expands when it is heated. Normally, whenever we'll be talking about liquids and heating up of a liquid, we will be heating up this liquid in a vessel. Yes or no?
Yes, sir.
Water is heated in a beaker. Milk is heated in a beaker. So we expand it or we heat it in a beaker. Now, when we heat this in a beaker, we must now also understand that this beaker also gets heated up. Yes or no?
Yes, sir.
Now, whatever expansion that we see of liquid expanding in a beaker or in a solid body or a container is not its real expansion, is something that we call it as apparent expansion. And that is the next heading, apparent expansion of a liquid in a container. Apparent expansion of liquid in a container. So I have a liquid here. Its density is rho L, volume is VL or V naught or whatever. Then I have a container. Density is rho S of the container. Volume is Vs. The expansion coefficients are gamma L and gamma S. Do we understand this?
Yes, sir.
Okay. Now, here we have assumed that both the volumes are equal. That means this liquid is completely filled up till the top. Yes or no?
Yes, sir.
When I change the temperature by delta theta, volume of the liquid changes. This is the actual volume of the liquid when the temperature changes by delta theta or delta T. We understand this?
Yes, sir.
This gamma L can now be called as coefficient of real expansion. So I'm just adding the term real expansion of liquid. Do you understand why I've added this term real expansion?
Yes, sir.
Because I need to calculate or I need to formulate another term which is apparent expansion. Okay. Now, at the same time, when I'm heating up the liquid, the container also gets heated up. So this is the volume of the container when the temperature is changed by delta theta or delta T. Yes or no?
Yes, sir.
So some amount of liquid will overflow. I just gave you example of beaker and that something. So how much is the amount of liquid that will overflow? VL minus VC. So this will be the amount of the liquid that will overflow. Yes or no?
Yes, sir.
So then we can calculate something known as gamma apparent, which is gamma of the liquid minus gamma of the solid or the container. So this is the apparent expansion. Someone was asking me in class 1 what is apparent expansion. That was not the time to tell you what is apparent expansion. This is the time when I tell you that. You understand this?
Yes, sir.
Please note it down.
Sir, unmute yourself. Sir, unmute yourself, sir. Sir, you are not audible.
If gamma L is greater than gamma C, the level of liquid will rise. You understand this?
Yes, sir.
If gamma L, this will not happen at all. You cannot find a liquid whose apparent expansion, whose expansion is more less than the solid. But if you have a theoretical case, the level of liquid will fall. Yes or no?
Yes, sir.
Okay, so this is a simple explanation of what we are supposed to do. And you might encounter a question where you are given something like this. I have seen question coming in JEE on based on this. So you have a liquid bulb and you have this uh, limb like this, and then you heat this bulb and they ask you how much is the rise in the height of the liquid. Do you understand this?
Yes, sir.
So how do you do this? So you first draw this diagram. Do you understand what is this?
Yes, sir. Yeah.
We are finding out the change in area, and here we are finding out the change in the apparent expansion of the liquid. Do you understand this?
Yes, sir.
Draw this diagram. So this is just a question that has been taken up from one of the questions. The question was there, and we are just using the alphabetical orders. So you can put here the question number 1. What is the increase in the height? Have you drawn this diagram?
Yes.
Then you can find out what is the increase in the height of the liquid, or what is the final height of the liquid, and this is the final height of the liquid that you will get after all these calculations. Do you understand this? Do you understand how it is achieved, bacha?
That's expensive.
So this is just a question. It is one of a difficult question. If you get it in an examination hall, you might not be having time enough to solve it. So you just write it now and you remember how it is done. Will you be able to remember this, bacha?
Sir, once expensive.
Please note it down. Don't worry. I've already sent you the sheet. So, but reading from a sheet is a different thing, and writing it with your own hands is different. When you write it with your own, you will remember it. The probability of you remembering it is more. The probability of you remembering it is more. Okay. Noted it down?
Sir.
Okay. Then there is a simple question based on this. A glass vessel of volume 100 centimeter cube, initial volume filled with mercury, top to bottom, heated from 25 to 75. What volume of mercury with overflow coefficient of linear expansion? Remember, for solids, normally linear expansion is given. Is this, you can see it is 10 raised to the power minus 6. Coefficient of volume expansion of mercury, let us see 10 raised to the power minus 4. Remember, one is linear, the other one is volume. You have to find out how much volume of liquid will overflow. How will you find it out? So much have we got this?
Yes, I got.
This is V naught
You know.
into apparent expansion, gamma L minus gamma S. How do you find the value of gamma S? You multiply this by gamma, this multiply alpha S by 3, and you multiply it by the change in temperature. Got this?
Yes, I got.
Okay. That takes us to the last part of this. And the last part of this is the next heading, which you will write now. Variation of the force of buoyancy with temperature. We have just seen a question where the wood was floating in benzene, but then you start heating up that mixture, benzene or whatever. Then you found out that the wood started to what? Started to sink. Why did it sink? It also expanded, this also expanded, this volume decreases, but the decrease in this volume is much more, the decrease in the density is much more than the decrease in density of this, and hence they start to sink. Yes or no?
Yes, sir.
Now this is the case only and only when the body is submerged completely inside the liquid. So body is already inside the liquid, the body already sunk. So we are just doing the case when the body has already sunk. Do we understand this case?
Yes, sir.
For the solid body, what is the buoyant force? Is V naught, the entire body is inside. So V naught into dl into G. Do we understand this?
Yes, sir.
Volume of the body after increase in temperature will be this. Do we understand this?
Yes, sir.
Density of the body after is increase in temperature. Density of the liquid hoga ye. Density of the liquid, not the body. Density of the liquid will be this. Do we understand this?
Yes, sir.
What will be the new buoyant force? The new buoyant force will be this, and then you can find the ratio, and this is what you got to remember. FB dash, which is the new buoyant force, divided by FB, which is the old buoyant force. The ratio is this: 1 plus gamma S into delta theta divided by 1 plus gamma L into delta theta. This is the most important factor that you must remember in this particular question. Do we understand this?
Yes, sir.
Please note it down. Do we understand this, bacha? This is the question that has come many times in JEE Advanced, JEE Mains. What happens when you increase the temperature? This is the most likely question because it involves heat, thermodynamics, it involves buoyancy, liquid. So this is one of the more important questions.
Density of liquid.
Do we get this, beta?
Sir, volume of liquid does not change.
What is the problem? You just note down the formula. That's it. Yes. What is the problem?
Volume of liquid does not change.
Volume of
liquid.
why I'll be concerned by volume of the liquid? I don't understand this. Do you have a doubt? What is the doubt?
Second.
There are only two things that I am concerned about. How much is the volume of the solid? Because that is the volume of the liquid that is displaced. The entire solid is inside the liquid. So I just need to concentrate on the volume of the solid. That much volume of the liquid has to be displaced. Yes or no?
Yes, sir.
Okay. Have you noted this down?
Yes, sir.
Now, in all the cases, then gamma of solid will be less than the gamma of liquid. Yes or no?
Yes, sir.
So the new buoyant force will be less than the original buoyant force. Do we understand this?
Yes, sir.
When the buoyant force decreases, the apparent weight will get increased. So you can get multiple choice question in JEE Advanced. What happens to the apparent weight? The new apparent weight is W minus FB dash. The old apparent weight is W minus FB. Do we understand this?
Yes, sir.
This is the class for today. We will be doing one or two questions on based on this in the next class. So I will wind up this class today. Here we'll be solving some questions based on the entire chapter in the next class. 2 or 3 questions, 3 or 4 questions, and that will cover everything that we have done so far. Is everything clear up till now?
Yes, sir.
So we have finished this. The only thing that is left is expansion of gases, which I'll give you 2 formulas, and that will be good enough for your entire curriculum. So we'll do that in the next class. I'll see you in the next class. Take care and have a nice day.